Okay, so welcome, and here we're going to go ahead and we're going to do a couple of examples using one of those special products. So in this case here, all we're doing is distributing, right? So we can't combine these, so all we're going to use is the distributive property and we're done. So that means we're going to distribute the 6 to both multiplying by the 3 and multiplying by the 2. So this gives us 6 times 3r plus 6 times 2s, which gives us our final answer of 18r plus 12s, and we're done. Okay, now this one here, we're going to use the distributive property twice, okay? So first thing we can do is we can distribute the 3r to this and this. So watch what happens. So this is going to be 3r times 3r, plus, minus, because we're doing minus, so positive times a negative. So this is going to be minus 3r times 2s, and then now what we're going to do is we're now going to distribute the 2s to both of them. So that's why I say we're doing the distributive property twice. And so if we do that, then we get what? We get a plus 2s times 3r minus what? 2s times 2s. Okay. Now, notice we get what? Well, 3 times 3 is 9. R times r is r squared. Minus 3 times 2 is 6. R times s. And then we get plus 6 rs. And then we get minus 2 times 2 is 4. And then we get s times s, which is squared. And notice what happens here in the middle. We get a minus 6rs, we get a plus 6rs, and so these cancel each other out. We end up with just the square of the ends with a subtraction. So we get 9r squared minus rs squared. And this is known as the difference of two squares. So anytime you're multiplying two binomials where they're exactly the same except opposite signs, you know, here it's plus and here it's subtraction, addition and subtraction, you're always going to end up with the middle canceling out, and you end up with the square of the first term minus the square of the second term. And so notice how this is just 3r quantity squared minus 2s quantity squared. So the difference of two perfect squares. And that's how you do these. Okay? And so the final answer is right there. Okay, see you next time.